Greetings and welcome. In this video session we are going to discuss about basics of fluid statics. In this session you will be able to explain what is fluid statics, what is pressure, Pascal's law and applications of Pascal's law. What is fluid statics? Fluid statics is a branch of fluid mechanics that deals with study of fluid at rest. For example, here is a reservoir of water, that is storage of water, which is called as dam. In this case, there is no relative motion between adjacent fluid layers of this water as a fluid. That's why study of such fluid is done in a fluid statics. In case of flowing fluid, here we find this fluid is flowing in the form of different layers. So here velocity gradient is existence, that is called as du upon dy. So here one layer is trying to drag another layer, so that's why there is shear stress which is developing between the layers. But in case of stationary fluid, as there is no velocity gradient present, thus there are no shear or tangential stresses in the fluid. In this case, only stress which exists is normal stress, which is the pressure, and the variation of pressure is due to the weight of the fluid. So here we find this is a wall against which this is a storage of water. So this wall is subjected with this force, and the force is equal to pressure into area, because pressure is equal to force upon area. Let us see some examples where fluid statics is required. Fluid statics is used to determine the forces acting on floating or submerged bodies, as ship. Fluid statics is used to determine the forces developed by devices like hydraulic presses, hydraulic car jacks, and the design of many engineering systems such as water dams, liquid storage tanks, which require the determination of the forces acting on the surfaces using fluid statics. In each of these situations, what we have seen, fluid is in static equilibrium with respect to a reference frame attached to the boundary surrounding the fluid. Here we see a plate which is exposed to a liquid which is present on the another side of this dam wall, such as gate in a dam. Also here the wall of a liquid storage tank, and the hull of a ship which is at rest is subjected to fluid pressure distributed over its surfaces. So in most cases, here we see the other side of the plate or wall is open to the atmosphere. What is pressure? Pressure is defined as a normal force exerted by a fluid per unit area. Mathematically, capital P is equal to F upon A, where F is a force, normal force, and A is a area. In case of gas or liquid, we use term as a pressure, and in case of solid, this ratio force upon area, for that we use word or term as a normal stress, but meaning of both is same. Now by the definition or this formula, unit of pressure is Newton per meter square. Newton is unit of force, meter square is unit of area. This Newton per meter square is also called as Pascal. This is smaller unit. For the calculations, we need different units of pressure. This is a unit, bigger unit, that is kilopascal, which is equal to 10 raised to 3 Pascal. One more bigger unit is used, that is megapascal. 1 megapascal is equal to 10 raised to 6 Pascal. These are some other units. 1 bar, that is used to measure barometric pressure, that is equal to 10 raised to 5 Pascal. In megapascal 0.1 and in kilopascal 100. In the form of atmospheric pressure, 1 atmospheric pressure is equal to, in a Pascal, this is a value, in a kilopascal, here this value is mentioned, and in a bar it is 1.01325 bar. In MKS unit, pressure is expressed as kilogram force per centimeter square, means kgf per semi square. Its conversion into Pascal, for that this is a Newton per centimeter square value. This is in Newton per meter square value. So finally we find this in a Pascal. Same conversion to the bar and atmosphere is given from kilogram force centimeter square to bar and atmospheric pressure. Here in the fluid static, Pascal's law is used. It states that pressure or intensity of pressure at a point in a fluid which is at rest is same in a magnitude in all directions. In other words, Pascal law states that pressure applied at a point in a fluid at rest is transmitted equally in all directions. So here we find this is the left side, piston 1, where application of force by the piston on the oil, the pressure is developed. This pressure is transmitted in equal magnitude here, and it is transmitted to the second piston equally in all direction. Now here, in order to understand Pascal's law, we need to know pressure at a point, which is required to verify Pascal's law. So pressure as being the infinitesimal normal compressive force divided by the infinitesimal area. That is what definition of pressure, over which it acts, is called as the pressure at a point. This can be demonstrated by considering a small wedge-shaped fluid element of unit length in equilibrium. So this is called as wedge-shaped fluid element. Let us see its dimensions. It has 3 main planes. One is a vertical plane, this is horizontal plane, and this is inclined plane. These 3 planes are subjected to the pressure. So pressure in horizontal direction is acting, that is Px along x direction. Pressure is acting in vertical fashion, that is along y axis, that is Py. And on the third plane pressure is acting, that is Ps. So that is acting along the z direction. So these 3 pressure components are acting normal to the respective planes. So here we will have these areas. So these areas we will use in the further proof. This is a proof of Pascal's law. So consider an arbitrary fluid element that already we have seen, vase shape fluid element at rest. So here are the dimensions are given, already we have mentioned, but only thing is that here theta, that is what angle of wedge with respect to x direction. So here by this, here we will have this sin theta ratio, means front side dz divided by this ds, and cos theta ratio, that will be adjacent side, means dx divided by ds. So simplifying this relation, we can write for dz is equal to ds sin theta, and we can write for dx equal to ds cos theta. These two relations we will use in further mathematical steps. Now here the forces acting on the element are of two types. First, pressure forces, which are normal to the surface. So these forces are which are in x direction, means all the horizontal forces will be pressure forces. And second kind of force, that is weight of element, that is acting in vertical fashion, means along the this direction, z direction. So first of all, let us see one by one. In a first class, means pressure forces which are in horizontal or along the x direction, that we will first of all see. Now the force definition, by the definition, as pressure is equal to force upon area, so force will be equal to pressure into area. So first of all, we will enlist the forces on the respective planes. So this is the first A, B, C, D. This is a plane, inclined plane. On this force, on this plane, the force which is acting, that will be what? This pressure PS multiplied by this area of inclined plane, that is ds side multiplied by dy side of this rectangular area. Another face, that is ABEF. So ABEF means this vertical plane on which the force is acting, that is acting along the x direction, that will be equal to what? Pressure intensity Px along x direction multiplied by this area, means dy, this side multiplied by another side dz. And the third force which is acting in a vertical way, means along z direction, this force will be what? Intensity of pressure Pz multiplied by this area, horizontal plane area, means this dy into dx. So this is a dy side and multiplied by this another horizontal side, that is dx. Now in the same way, we will first of all write down the formulae. In a second class of the force, that is weight. Now definition of weight. Now we know that here this weight is equal to mass into gravity, acceleration due to gravity, means capital W is equal to mg, that already we know in physics. But mass, how to write? We know that density is what? Ratio of mass upon volume. So mass will be replaced here with this product, that is density into volume. So weight of the element will be equal to density into volume into acceleration due to gravity. Now density is rho and volume of this vase shaped element. that will be what? Area of the element, means this frontal area, this triangular area will be what? Half into this base, means dx, into this another side dz, means half into dx into dz. This will be area of this frontal triangle multiplied by this another dimension, that is depth, means dy. So this half dx dz area into dy, that will be what? Volume, multiplied by acceleration due to gravity is g. Further, as we know from the fluid properties, rho into g, this product is called as specific weight. So for the specific weight we write here gamma. So capital W is equal to, formula comes gamma upon 2 into dx dy dz. So this is what? Volume, where gamma is specific weight of the fluid. Now we have defined all the forces. Now we will take here equilibrium condition for the balancing of the forces. So in this left side, resolving all the forces in x direction. So here in x direction, the forces which will be directing towards right direction will be taken as a positive sign, and the forces will be directing in left side will be taken as a negative sign. So let us see first force, px dy dz. So this is a force which is acting on this ABEF plane, and this force is along x direction. Px will be positive, px dy dz. Then another force, that is result component of this ps. So horizontal component along the x direction of this ps will be what? Ps sin theta, intensity of this pressure, ps sin theta, multiplied by area. Now area of this inclined plane, that is ds into dy. So that is what is written here. Now it is in opposite direction, left direction, that's why minus sign. So minus ps ds dy sin theta is equal to 0. Now in this expression, if you see here, we find dy ds sin theta, and also here dy ds sin theta. So from this equation, dy ds sin theta can be cancelled. So what remains? That is what? Px, and this minus ps, when we bring on the another side of the equation, it becomes positive ps. So we get here px is equal to ps. Give the number, equation number 1. Now in the same way, resolving the forces in z direction, means vertical forces. So in that, first of all, the force, that is pz into dy dx, pz into dy dx, means this force which is acting on this EFCD plane, means this bottom plane, and it is acting in upward direction, so take positive sign. Next force, that will be what? Resolving vertical component of this ps. So resolving component of this ps will be what? Ps cos theta, because the angle is here, that is theta between these two. Ps cos theta. This is pressure intensity multiplied by area. Area is what? This area ABCD plane, means dy ds. So again it is acting in downward direction, that's why sign will be minus. So this force will be what? Minus ps ds dy cos theta, this force. Next force which is acting as a weight component, that is already written here, gamma by 2 dx dy dz. As it is acting in downward direction, weight, that's why its sign is minus or negative. So here now as per the definition of this wedge shape fluid element, we say that it is infinitesimal element, means dx dz dy, all these are very small, and product of this, that will be nearly equal to 0. So that's why this term containing dx dz dy, that can be ignored because it is nearly equal to 0. So rest of the terms are here, pz dy, and for this dx already we have written here ds cos theta, so we will take here ds cos theta. Next to that, minus ps ds dy cos theta. Now in this expression you see dy ds cos theta, and here also dy ds cos theta. So this can be cancelled. So here we can write pz, remaining term, and this minus ps, if we bring on the other side of the equation, will become positive. So we find here pz is equal to ps. So say equation number 2. Now from equation number 1 and 2, here px is equal to ps, here pz is equal to ps. So we can write px is equal to pz is equal to ps. So it verifies the Pascal's law, means what? Intensity of pressure acting along x direction, y direction and z direction, all are same. So it means Pascal law is verified. Let us see some applications of Pascal's law. Pascal's law is used in the construction of machines such as hydraulic press, which is commonly used for the different operations, that is blanking, that what we see here. This is what blanking operation means, making a large hole, rectangular or any kind of shape, hole in this sheet, metallic sheet. The other operations can be carried out. These are punching operation, deep drawing and metal forming operations. Hydraulic jack, it is a device that is used to lift loads like car, truck during service by applying a force via hydraulic cylinder, which is shown here below this, here in this frame. Hydraulic crane, it is used for lifting and hoisting. In this case, fluid filled hydraulic system that enables the crane to transport objects such as heavy shipping containers from one location to other location. Hydraulic excavator, this is a heavy machine that has various sizes, a hydraulic arm with a blade at the tip, which is designed to excavate, rotate, move, load, mobilize and demobilize objects. So at the end of this session, you can explain what is fluid statics, what is pressure, Pascal's law and applications of Pascal's law. So subscribe the channel Thermal Engineering for remaining video sessions. Thank you.